In this lab, I'm going to build a single node Kubernetes cluster on an EC2 instance. This is our bare metal style environment for CNI troubleshooting. I'm in the AWS EC2 console. I'll click Launch Instance. I'll name this instance something obvious like single node bare metal. I'm choosing Ubuntu Server. Now we reach a super important step, instance type. I'm going to pause right here because Kubernetes has minimum resource guidance for kubeadm-based clusters. Let's quickly jump to the official Kubernetes documentation and confirm the kubeadm prerequisites. Here's the key requirement. kubeadm expects at least 2 vCPUs and enough memory for control plane components. Now, let's jump to our training repository. I already have a kubeadm EC2 user data script prepared, so we don't waste time manually running installation steps. I'll copy the user data script from the repository. Back to our EC2 creation wizard, you'll notice I'm not creating or downloading a key pair here. For this lab, we'll use EC2 Instance Connect to access the instance directly from the AWS console. This avoids key management altogether. Now I'll paste the user data I copied from the training repository directly into the user data section under Advanced Details. This script will fully bootstrap our single node Kubernetes environment for us. With that in place, I'll go ahead and create the instance. At this point, AWS is launching the EC2 instance and executing our user data script automatically. While the instance is initializing, this is actually a great time to look at what our user data script is doing behind the scenes. Understanding this will help you troubleshoot Kubernetes in the real world. The script updates packages on our EC2. It also enables our EC2 to forward IPv4 packets. Next, it installs the container runtime, which Kubernetes needs to run containers. After that, it installs the Kubernetes tooling, namely kubeadm and kubectl. Then kubeadm initializes a single node cluster, which means this one EC2 instance will act as both the control plane and the worker node. Once the cluster is up, the script installs Calico as the CNI plugin, which is responsible for pod networking. Let's jump back to the EC2 console and connect to our Kubernetes node. I'll start by running the kubectl get nodes command to confirm everything is in order. Our worker node is showing a not ready state, which isn't ideal, especially considering the node has already been running for about 117 seconds. Let me run the command once more. Still not looking good. Next, I'll check whether our system pods are running by querying the kube system, namespace, kubectl get pods -n kube system. Right away, I notice that there are no CNI pods present, which is very likely the root cause of the problem. A Kubernetes node will never transition to ready if the CNI is missing or broken. This suggests that our Bootstrap script may have failed to install the CNI. To fix this, I'll jump over to the Calico project page and copy the CNI manifest download command. Back on our EC2 instance, I'll download the Calico CNI manifest. Running ls, we can confirm that the file has been downloaded successfully. Now I'll apply the CNI manifest using kubectl apply. Let's check the system pods again, and this time we can see the Calico pods being created. After a short while, the Calico pods move into a running state. Finally, when we run kubectl get nodes again, we can see that our worker node is now ready and healthy. At this point, we have a fully working bare metal single node Kubernetes cluster up and running. If you're using an EC2 instance as your Kubernetes node, you can stop the instance when it's not in use. That way, you only pay for storage and not for the instance size. You can restart the same EC2 instance at any time and continue to follow along and experiment with Kubernetes networking. Thank you for watching and happy networking.